All right, so hello and welcome to the first asynchronous lesson for this week. I guess we'll be working on these between September 25th, that's Thursday, and September 26th, which is Friday, because we have some people going to the Independence House programming rather than doing everything together. Figured we would do asynchronous lessons, so the vision is that if you are in class both days, then you'll be able to do the first lesson in class Thursday, the second lesson in class Friday, and you will not have homework. If you are either not in class for one of those days, or if you are in class both of those days, but you didn't take the test Wednesday, meaning you have to take it Thursday, then you'll be able to do one of these lessons, whichever day, right, Thursday or Friday, whichever day you're in class and available. And then the other one, you can either start in class, because I'm not scheduling these to try and take the whole 50 minutes, or you can do it for homework. So that's kind of the idea here. Two lessons, each of them shorter than a normal lesson, and you can do them at your own time, sometime before Monday. So the first one, I'm going to talk about pages 2 and 3 in the new notes package. This is Unit 2. We're talking about functions, but before we can talk about functions, we have to talk about relations. And so the first blank here is a relation is a set of ordered pairs that connect input values, often labeled x, with specific output values, often labeled y. So it's a pairing, right? Every x value has a corresponding y value. And a relation can be discrete, meaning that's defined for only specific values of x and y. That's what we see over here, right? This is a discrete relation because we have 4 different discrete sets of x and y values, right? -6 goes with, or -3 for x goes with -6 for y, 8 for x goes with 9 for y. But they can also be continuous. And that means that they're defined for a range of x and y values for an interval. So as we can see, this over here is a continuous relation. Every point on the line corresponds to a point in the relation. We can see that for all x values between 4 and 8, not including 8, there is a value in the relation, and for all values of y between 2 and 8, there is also a value for the relation. So these are a bunch of coordinate pairs, but there's infinitely many of them spread out around this line within those intervals. So when we're describing relations, we say the domain is the set of all x values for which the relationship is defined, and the range is the set of the y values for which the relation is defined. So the domain is the input, what can you input, and the range is the output, what can you get out of it. For discrete functions, we write the domain and range as a set. So for the domain, I'm going to put the little curly brackets to tell me that this is a set that we're looking at. And it's a set that contains all of the x values for which the function is defined. So for that, I'm going to go -7, -3, 6, and 8. Right, those are all of the potential x values that this function can take on. And we always write them from least to greatest, right? So whether you're doing domain or range, write them from least to greatest. So for the range, it can be -10, -6, 5, and 9, right? Those are all the y values that the function can take on. Again, written from least to greatest. All right, instead of with continuous relations, we can't just list the numbers, right? Because there's infinitely many of them, so we have to use something called inequalities, right? So we have to create a range. So for this one, we want all x's between 4 and 8. One way we could write that is you could say all values x for which 4 is less than or equal to x is less than 8. Okay, so that's one way of saying from 4 to 8. And notice how 4 I put less than or equal to. That's because this is a filled in circle, so we know 4 is part of our domain, right? The function is defined here. but I left that open for 8, right? That's an open circle. 8 is not part of the domain. The domain is from 4 to 8, and we can do, in this line, so you would read this, all values x. So the curly brackets mean we're looking at the set that contains all values x such that, or where, this horizontal line means that like we're putting a condition, we're given more information on this, so subject to the condition that x is within this range, or within this interval. Let's not mix up our words there. So for the range, we're going to do a similar concept, but now we're doing all values y, because the range is outputs. And now we're going to go 2 is less than y is less than or equal to 8. And so you'll notice the domain, that's from here to here. Right, those are all the x values for which the function is defined. Whereas for the range, it's all of these ones. These are all the y values for which the function is defined, 2 to 8. And we're being inclusive on the side that it is included and exclusive on the side that it is not, marked by a closed circle for inclusive, open circle for exclusive. All right. And sometimes continuous functions will go on forever in the x or y direction. When that happens, we're going to use infinity to represent. So if it's one-sided, then we use infinity. If it's two-sided, infinite, we do something different. So I'll show you that in a minute. So let's start with the domain. We can see that the domain starts at -1 and goes on forever. So for the domain, we can write the set that contains x such that x is greater than or equal to -1. I misspoke. We're not going to use infinity yet. We'll do that on the next page. Here we can just say where x is greater than or equal to 1, right? You can do a one-sided inequality because everything to the right of -1 works. Right, but for the range, if we imagine this function continuing on forever, it's going to continue to go up, it's going to continue to go down, so it gets to all y values, right? It continues on to positive infinity in the y direction and down to negative infinity in the y direction, meaning that we're going to write y, where y is a member of all real numbers. So this is kind of a set phrase. You think about it this way. All values y such that y is a member of this crazy looking R. The crazy looking R means all real numbers, and it just means take everything, right? As long as it's on the real plane, any values of y work. All right. So if we go on to page 3, we have two different ways that we can write domains in range. Right? We have interval notation and set notation. So what I was just showing you was set notation. So for this one, we saw that the set notation for the domain, all values x, where x is greater than or equal to -1. And for the range, it was all values y, where y is a member of the real number. So that was set notation. And we have the curly brackets there that tells you it's a set. For interval notation, we're going to write it as an interval. So we're going to think about what are all of the numbers. We're going to have two numbers here. The first one is going to be the smallest number in the set, and the second one is going to be the biggest number in the set. So what's the smallest number in the set here? Well, that's -1. And what's the biggest number in the set here? Well, it goes on to the right forever. It keeps going. So there is no biggest number, so we use infinity instead. And now to capture these, right, to kind of get them all together, we want to either use a parenthesis or a bracket. If the number is included, so in this case -1 is included, we'll use a bracket. But if it's not included, we use a parenthesis. And so, looking over here, this one infinity is not a number, so we can never include infinity. So if it's infinity, it's always a parenthesis. So in interval notation, that means -1 to infinity. Right, and then what do you do if it's all real numbers? Well, then it goes all the way from negative infinity up to positive infinity. And because they're both infinity, you put parentheses around it like that. And then in example 2, down here, the same thing. We already did the set notation there. So for the domain, it was x, where 4 is less than or equal to x, which is less than 8. And then for the range, it was y such that 2 is less than y is less than or equal to 8. All right. And so now for interval notation, we want to think about what is the smallest x value that's included. That's 4. And it's a closed circle, so we're going to put a bracket. What's the biggest number that's included? Well, that's 8, but that's not included, so we're going to put a parenthesis. And for the range, you can put parenthesis. 2 is the smallest number, but it's not included, all the way up to 8, which is included. So that's how you would write the domain and range in set notation. So I'm going to give you a second, take a look at these two functions down here, see if you can write the domain and range in set and interval notation on your own. Pause the video, try and figure it out. Once you're done, keep playing the video and I'll write down the answers. Right, so hopefully you have these ones filled out. So for the set notation for this function, we can see that it goes from -4 up to 4. Sorry. So I'm mixing it up. The interval notation, that is all values x, where -4 is less than or equal to x is less than or equal to 4. In the interval notation, that's from -4 up to 4. And for the range set notation, we're going to have all values y, where 0 is less than or equal to y is less than or equal to 4. And for interval notation, we're going to go bracket 0, 4. All right, and then over here for the domain, for the set notation, we're going to do a set that contains all values x, where x is less than or equal to 6. Just notice this arrow means we're going to go on forever in that direction. Meaning for our interval, it is -infinity up to 6, and 6 is included, so we put a bracket. For the range, for the set, it is all values y, where y is greater than or equal to -2. And even though it looks like it stops here, we see that it goes back down and then continues up. So it does go on to infinity. So we can write that with an interval notation as -2, infinity. And we'll do more practice with this in class next week. So if you have questions about this, feel free to call me over and ask, or if I'm not in class, shoot me an email, or just wait until next week and we will practice with this together.